As we discussed before, income streams can be given as just an amount of money or as a function. So in example E, we have income flowing continuously at a rate of f of t equals 15,450 times e to the negative 0.045 t dollars per year, where t is in years. So in part A, they're asking us to find the total money flow, okay? Total money flow over the first 7 years. That total, remember, think accumulated total money flow. That's an integral. So we're going to take the integral from 0 to 7 of our f of t function. And when we put that in our calculator, we get approximately $92,772.49. Now, one thing to note, the money flow, that's the income stream total before any interest is earned. In part B, we're to find the future value if it is invested at 6% compounded continuously. So again, they're giving us the R value of 6%. So our future value formula is E to the R times T. It's still over 7 years. Integral from 0 to 7 of now our function. Let's make sure we understand what all of these parts are. This is E to the R capital T. This piece here is our income stream function. And this is our e to the negative RT. So we've done this before. It just looks different because now we have an entire function for our f of t. Put all this in our calculator and we get approximately $116,562.55. So part A was without interest earned, just pretty much how much money we put in there. And part B is with interest. Now I'm going to scooch up just a little bit here. What if, in part C, we want to find the present value if it's invested at 6% compounded continuously? In other words, how much would we have to have in our pocket right now as a lump sum to deposit, never touch again, and still have the same amount of money after 7 years? So remember our formula for the present value. We're going to take the integral from 0 to 7. And if we put that in our calculator, we get a p-value of approximately 76,587.05. That's how much we would have to invest right now to get that same amount of money at the end of 7 years. So let's check that. What would be our account balance using our PERT formula if we deposited $76,587.05 continuously at 6% interest for 7 years? Plug that into our calculator and we get approximately $116,562.55. Now, the future value of an annuity compounded continuously is the integral from 0 to capital T of p to the er little t dt. Or once again, A is our future value, P is the dollar amount of the deposit per pay period, where R is the annual rate. However, it is divided by the number of pay periods per year. Okay, so again, this is an annuity compounded continuously. T is still the time as a variable, and capital T this time is the number of pay periods considered. So we have to figure out what those pay periods are going to be. So looking at example F, at the end of each month, $600 is deposited into an account. So that is our P, $600. It's like a principal, right? But it's deposited every month into an account. Now the account is paying 5.75% But we need to consider how many times it is going to be paid per year, okay? So again, pay periods per year. So if $600 is deposited at the end of each month, we would divide this by 12. I mean, it's approximately 0.0048, but to be more exact, we would plug in that entire fraction into our calculator. And then it says find the future value of this account after 60 months. It's 5 years, but everything is in terms of months, so we're going to keep our capital T as 60. So our account balance, or the future balance, after 60 months, is going to be the integral from 0 to 60 of 600 times e to the 0.0575 divided by 12 times t dt. So if we plug that into our calculator, we get approximately $41,719.66.